Hello again! Welcome back. This is Becca, often going by Nightcat or Nightcat's Meow when online, and this is another week of coding with Linden scripting language. I left a short little video explaining why I had missed doing one of these last week. Again, I'm apologies for that. Just kind of a whole mess of things going on, and it's kind of all ate up my time. And this week, there's not another freebie. Sorry for those of you that were really hoping for one. And for those that are looking for more simple projects, I think at this point it's time to start getting into the nitty-gritty. This is the point where we're really going to start going into more of the anatomy of a script and really dive into some of the programmer thinking and the structure that I've been sort of glossing over in an effort to help introduce people to the language quickly and simply. So we're going to start, as usual, with the Mark I cube. When you pop this open, we've usually just gone through and overwritten the things you see here, but now we're actually going to talk about them. It starts out with the default state. Now the thing is, I haven't done this with any of the videos that I've shown you so far, but it is possible to have multiple states. You can think of these sort of as sub-programs or entirely different ways that the code can operate. For most things that you'll do in SL, this isn't really all that necessary. This is really only important if you want it to toggle between two very, very different ways of working. That is a very sort of deep working thing. So most of the time, you'll stick with just your one default state. As we've talked before, with the state entry, that just happens anytime that this starts up. So basically whenever the script begins. And then the touch start, there's also a touch end. This is one of your interface modes. There are several of these. This is your listen. This is your change, which I actually haven't dealt with. Collision. Any one of those are just different sections that will trigger when a given thing occurs. Collision, the object hits something or something hits it. It can go either way. Touch start, that's when you click it. There's a touch end, that's when you remove the mouse click. That's really good if you want to set a timer for if it's clicked for so long, produce this effect. If it's clicked again in a certain period of time, you can still stay with touch start. It all depends on what you're going to do. What we're actually going to go through is just create something. It's not really going to be all that useful in world, but it's more just an experiment to work on understanding the thinking of a programmer, how something is going to work, how it is going to respond. What we're going to do is just create a simple thing that you'll interact with it, it will respond in very particular ways. Now, why are we doing this? Because the hardest part of programming is the mindset, the thinking process. I've talked in a couple of other videos about you need to add these extra pieces to make it work the way you might expect it to in the real world. The thing to keep in mind is a computer, and especially a computer program, will do only exactly what you tell it to do. When you're interacting with the real world, there's all sorts of things that you just take for granted, that just happen, that they just work a certain way. One of the challenges in programming in a virtual world like Second Life is that you have to account for every one of those details yourself. You have to think them through. You have to plan them through. And this process of thinking actually occurs in other programming languages also. You want it to go through and have a program deal with a bunch of different things. You have to figure out how to have it deal with each one of them. You have to figure out how is it going to respond if something goes wrong. You have to account for every one of these details, and then you have to make it work in a way that is approachable to the end user. So a lot of this complexity. If you're looking at programming as just a simple matter of you assemble a few commands to do a thing, that's the easy part. The hard part is the thinking behind it to know which parts to use for what, how to achieve the result you want, and how to make that make sense. So we're going to put together just a pretty simple little something here whose sole purpose is just to have something behave in a way that makes sense. So we're going to start, and I'm spelling that wrong, so we'll actually do what I've told you many a time, copy and paste directly from the wiki page, which you'll be seeing a nice little example of here. Alright, now when this detects a collision, that something strikes it, it will say, ow. Then set timer event 10. That means 10 seconds. And timer. And as sometimes happens, I forgot a tiny little detail up here. Congratulations if you caught it, but I didn't tell it what channel to say on. So we fixed that. Alright. So, we have a thing here on collision. It says, ow. Now we wait a moment. You jerk. Now, anybody that can tell me what is wrong with this right now? There it is. It goes, you jerk again, because nothing stops this. This is an example of you have to think through every tiny thing. So, set timer event 0. That will stop the countdown to saying, you jerk. Now another example of, well, if this were a real-world object that you could accidentally step on, what would you expect somebody to do? You might expect them to apologize. So state entry, listen, 0, comma, null key. We can't know who this is going to come from, if it's going to be fed by whoever happens to wander in. And then, of course, we have to process the listen event, which we've been over this part in a few other cases before. Integer channel, string what. And this corresponds directly to these up here, by the way. 0, the channel you're listening on. We established when we were dealing with the sword drawn sheath that this, you can tell it what name it is listening for. You can also tell it to listen for a specific key to listen for. And then finally a string that is the message. If message equals sorry, say, now if, whoops, forgot a quotation mark there. It goes, ow. You say sorry, it says, okay, just be more careful, please. And then it goes, you jerk. This doesn't sound like our box is being very polite. This can be solved by taking the timer 0 up to here. Now when you apologize and it says, okay, just be more careful please, it will stop the timer to stop this. Save. Walk across it. The box goes, ow. I tell the box, sorry. It says, okay, just be more careful, please. Now, the next thing we're going to look at is, what if somebody were to say, I'm sorry, or so sorry? Well, let's find out what will happen. Say it didn't respond. And it calls me a jerk. That's because the string, I'm sorry, did not exactly match sorry. There is actually a thing that we can do to solve that. I'm going ahead and pulling up to remind me exactly how to format that real quick, since it's not one I use often. It is called substring index. So instead of saying if message equals sorry, if substring index source message string pattern sorry and we're not checking the message, we're seeing if the substring index and I just double checked that does not equal -1. -1 means that it does not turn up anywhere in the string. So now we walk over it. It says ow, and I say I'm sorry. It says okay, just be more careful please. We do this again with just sorry, just be more careful please. So you see, with each bit of complexity we add, we're making this mirror what you would expect from the real world more and more. This is an example of the kind of thinking that it takes to put together a program correctly. We're also delving into user interface, where if you're going to take a text command, it's very easy to specify exactly what that command is going to be. It's a little bit harder to leave room for how might a person respond? What other ways might a person use to express this? The other thing that if we're going to model this on the real world is right now it will just keep repeating this. However, if the same person were to step on you twice in a row, you might start to take that a little personal. So we're actually going to make a way for it to identify if you were the last person to step on it. How are we going to do that? We're going to make a global variable. Remember, everything above the state goes in the entire thing. So in this case, we want key stepped so at the end of all this, we're going to store the key. Stepped equals detected key 0. You want to have it at the end there after everything is processed, because if you put it up first and we try to compare it, if I were to put that up in here, stepped equals detected key 0, and then were to compare, like I'm about to, if detected key 0 equals stepped, well, we'd have just put it in there, so it would automatically be the same. We don't want it to work quite that way. In fact, we want this to be, if it does not equal, it goes along just the way that we had it. Else, because this was if it does not equal, so therefore the else means it must equal. There. Ow. I'm sorry. Okay, just be more careful, please. Then we go again. You again. Watch where you step, you jerk. So again, we're modeling something that resembles a more real-world kind of scenario. But you see how in order to represent that in a program, you have to break it down step by step. How should it behave? What is the logical response? You have to put yourself in the way of thinking of, what do I want it to do? In this case, we're modeling a talking floor tile. But it's the same kind of thinking if you're modeling a numerical system, if you're running financial projections, anything like that. Anytime that you're looking to write a program to do something, you need to be able to break down every step of the way how it should respond based on what is happening with it. If you leave anything out, the program isn't going to do what you expect it to do. And if you want it to be particularly user-friendly, sometimes you have to really dig down and find specific things in there that you put in to adapt to how the user may interface with it. So here we did the substring index, which basically means it's looking through this string to see where in there the word sorry shows up. And it would return a number that said which character in that text string was the beginning of the word sorry. All we really need to know is if it's there. So as long as this does not equal -1, it's in there somewhere. It was said. In fact, funny thing, you could actually say, whoops, have to actually restart this so that it forgets me. There we go. Oh, we found a little problem here because it registered a bump. It read that twice. So it told me, you again, watch where you step, you jerk. Right there. Boom. Automatically. So that's a thing that we want to make sure does not happen here. How do we do that? Simple. We make a flag in the system, integer, step equals false. So it detects the original step. Step equals true. Whoops, that does not need to be LL, so just step equals true. Then if step, shorthand for if step is true, return. Just get out of this. Just don't do anything with it. Step equals false. So when the timer comes through, it goes to step equals false. Or if it gets its listen, step equals false. So we've now gone through, we tested this. We found what would be called a logical error, where a particular set of circumstances can occur that will produce a behavior in the script you do not want. This is different from a syntax error, where something in how you wrote the script refuses to compile. In this case, it will compile. It will run. It just runs in a way you don't want it to. So, there we go. See, I can even back and forth on it a little bit, and it doesn't quite respond. Now, the last thing that I wanted to address in terms of the thinking process for this particular thing is I'm going to have to reset this so I can show you one little bit of snark you can use that the program currently can't identify. I can walk across that and say, "So not sorry." And it just says, "Okay, just please be more careful." It only checked that the word sorry was in there. It didn't take into account not. So, before I leave you today, we are going to add in a AND statement. Substring index, message, comma, not sorry, equals -1. So it is making sure the word sorry is in there and that it does not contain the phrase not sorry. You can use not anywhere in there as long as it's not partnered to the word sorry. I see the problem. Forgot to close that parentheses. There we go. So, across ow, so there you have it. We've modeled a very simple version of a talking floor tile that doesn't like being stepped on. Hopefully this has helped you understand the thought process needed to go through and look at a seemingly normal proposition, a normal set of things that can occur, and how deeply you have to go through and think about how do I make this represent correctly with my program? What steps do I need to follow? And if you really want to use a technical term, that is an algorithm. What algorithm do I need to have this follow to do the thing I want it to do the way I want it to do it? So, that has been this week's lesson on Linden scripting language, really more of a general programming lesson using Linden scripting language, but either way, I hope you all enjoyed that. If there's anything that's not being explained clearly enough, please leave a comment. I will happily go through and do additional videos explaining it, and I will make sure to cover it better in future videos. If there's anything that you particularly want me to cover, go ahead and drop me a comment as well. I can respond to that. Anyway, that being said, I'll have more of these up. They are set to be released every Tuesday at noon. So, hope to see you back. Until then, good luck and happy coding!